Section 2, Pressure Vessel Safety Management. Part 1, Pressure Vessel Design and Manufacturing Management. The broad definition of a pressure vessel is a sealed equipment that holds gas or liquid and withstands a certain pressure. The definition, according to regulations, is shown in the figure. At the same time, there are many national legal standards that you need to be familiar with. The quality assurance system of pressure vessels includes design, manufacturing, quality inspection, and other processes. Design management mainly requires design units to have the technical capabilities and methods that are suitable for the category of pressure vessel they are designing, categories I, II, and III. They must obtain the relevant qualifications. What signatures should be on the pressure vessel design general drawing? Design, verification, and review signatures. Also, the chief engineer's signature and seal. The person signing must take responsibility. The pressure vessel design permit is valid for 4 years. It becomes invalid after expiration. The original manufacturing quality depends on factors such as material quality, welding quality, and inspection quality. The quality assurance system refers to the entire production process being systematically managed. Each key stage is strictly controlled. It is an organic system consisting of organizational structure, responsibilities, procedures, activities, capabilities, and resources. The written form of the Quality Assurance System is the Quality Assurance Manual. This manual is the guiding document for factory quality management work. What does the Quality Assurance Manual include? First, basic information about the manufacturing plant. Second, the technical capabilities of the manufacturing plant. Third, tools, equipment, and inspection methods. Pressure vessel safety use registration. The operating unit of the pressure vessel should, within 30 days after the pressure vessel is put into operation or after its commissioning, submit relevant documents and materials to the municipal level Special Equipment Safety Technical Supervision Department for registration and usage procedures. This will determine the safety status level to fully reflect the equipment's historical status, including design, major repairs, and other information. The operating unit of the pressure vessel must establish a technical file for the pressure vessel. The content includes: first, pressure vessel registration card; second, pressure vessel design technical documents; third, pressure vessel manufacturing, installation technical documents, and relevant materials. On the other hand, it is required to establish safety operating procedures for pressure vessels. When operating pressure vessels, attention should also be paid to: the operating unit of the pressure vessel should provide safety education and assessment for the operators. Operators must hold valid certificates. During operation of the pressure vessel, operators must remain at their posts and must not leave their posts without permission, in addition to normal operations. To extend the service life of the equipment, maintenance and care play an important role. The maintenance work for pressure vessels generally includes preventing corrosion, eliminating leaks, spills, and drips, carrying out maintenance work during the shutdown period of the pressure vessel. Part 3, Regular Inspection of Pressure Vessels. Regular inspection of pressure vessels refers to the process in which pressure vessels are inspected at regular intervals using various appropriate and effective methods. Inspections are required. Regular inspections are divided into external inspection, internal inspection, and comprehensive inspection. First, external inspection. External inspection refers to the online inspection regularly performed by professionals during the operation of the pressure vessel. Second, internal and external inspection. This refers to the inspection carried out by professional inspectors when the pressure vessel is shut down. Third, comprehensive inspection. Comprehensive inspection includes all the contents of internal and external inspections and also includes weld non-destructive testing and pressure tests. We have just discussed the general situation of inspection cycles. In general, the inspection cycle should be shortened. The following situations require waiting for internal and external inspections before performing pressure testing, regardless of whether it has reached 6 years. To ensure the smooth progress of the inspection work, the inspected unit must carry out some preparatory work before the regular inspection. First, the corresponding safety measures for calibration and inspection work. Second, clean the internal medium of the pressure vessel thoroughly. Isolate it from connected equipment and pipelines using blind flanges, and set up clear isolation markings. Third, for vessels containing flammable, toxic, highly toxic, or asphyxiating substances, they must undergo displacement, neutralization, disinfection, and cleaning. Additionally, samples should be taken and analyzed. Ventilation and safety rescue facilities should also be provided. The general procedure for inspection is shown in the figure. The basic requirements for inspection. Pre-service inspection should mainly focus on reviewing original data and external macro inspections. Non-destructive testing spot checks may be conducted if necessary. The contents of online inspection for the vessel. Online inspection includes the vessel body, interface areas, weld joint cracks, overheating, deformation, leakage, etc. The contents of internal and external inspections for the vessel are shown in the figure. Strength verification should be conducted in the following cases. A. Significant corrosion is present. B. Strength calculation data is incomplete or strength design parameters do not match the actual conditions. Third, the misalignment and corner angle exceed the specified limits. Part 4. Management of pressure vessel safety rehabilitation. Pressure vessels must be equipped with monitoring devices for operating pressure, operating temperature, and liquid levels, as well as safety protection devices for abnormal operating conditions. These devices are collectively referred to as pressure vessel safety devices or safety rehabilitation. The safety devices for pressure vessels can be divided into three main categories: safety relief devices, shut-off and leak stopping devices, and parameter monitoring devices. First, safety valve. When the pressure vessel operates under normal working pressure, the safety valve remains tightly sealed without leakage. When the pressure exceeds the set safety value, the safety valve automatically opens under the pressure injection effect. This allows the vessel to relieve pressure and prevent damage to the vessel or pipeline. So, what are the principles for setting up pressure vessels? First, for pressure vessels with design pressure lower than the pressure source. Second, containers holding liquefied gases must be equipped with safety valves. Third, when there are several devices in a pressure system, if there is no isolation valve in the system, and the system diameter is appropriate and there is no possibility of blockage, then consider it as one system. Safety valves should be installed only on key equipment, etc. What are the key factors in selecting a safety valve? The manufacturing unit of the safety valve must have a manufacturing license issued by the relevant national department to produce it. The product should have a certificate of conformity or quality certificate when leaving the factory. The certificate of conformity should have the stamp of the quality inspection department and the inspection date. The selection of a safety valve should be based on the process conditions of the vessel and the characteristics of the working medium. Consider factors such as the safety release capacity, loading mechanism, sealing mechanism, gas discharge method, and working pressure range of the safety valve. What issues should be considered when installing a safety valve? First, the safety valve should be installed vertically upward in the gas phase space above the liquid level of the pressure vessel body. Alternatively, it should be connected to a pipeline in the gas phase space of the pressure vessel. Second, if the safety valve cannot be installed directly on the vessel body and is connected to the vessel by a short pipe, the diameter of the short pipe must be larger than the inlet diameter of the safety valve. Generally, valves or other branch pipelines are prohibited from being installed on the connection pipe. A rupture disc, also known as a burst diaphragm or burst plate, is a type of fracture-type safety pressure relief device. Pressure gauge. A pressure gauge is a measuring instrument used to measure the pressure of the medium in a pressure vessel. There are many types of pressure gauges. The most commonly used pressure gauge in pressure vessels is the elastic element type, single spring tube pressure gauge. First aspect, selection of pressure gauges, key points. For pressure gauges installed on pressure vessels, the scale limit value on the dial should be 1.5 to 3 times the maximum pressure of the vessel, with 2 times being ideal. For low-pressure vessels, the pressure gauge should have a precision grade of no less than 2.5. For medium and high-pressure vessels, the pressure gauge should have a precision grade of no less than 1.5. The dial diameter of the pressure gauge should be no less than 100 millimeters. If the pressure gauge is installed at a high and distant location, the dial diameter should not be less than 150 millimeters. How should the pressure gauge be installed? It should be installed in the most prominent location with adequate lighting. It should be protected from radiation, low temperatures, vibrations, and other influences. The pressure gauge is generally installed vertically. The dial should be vertical to the operator's line of sight. If installed at a higher location, it should be tilted forward by 15 to 30 degrees for the operator's convenience. The pressure gauge connection pipe should be directly connected to the vessel body. To facilitate disassembly and calibration of the pressure gauge, a three-way rotating plug should be installed between the pressure gauge and the vessel. For pressure gauges used with steam as the medium, a water seal pipe should be installed between the pressure gauge and the pressure vessel to prevent high-temperature steam from directly impacting the pressure gauge. How often should the pressure gauge be calibrated? Every 6 months. That concludes this lesson. Thank you for watching.